rusty. Sorry about that. 3 minutes late. Well, Morgan's not here. He'd kill me. At this point...
Do you want me to kill you on his behalf?
Yeah, that'd be fine.
How could you do this, Fraser?
I know.
3 minutes late.
I know.
What do you think this is?
I'm trying to make French onion soup for my wife, trying to help my
Not
child
important.
gear up to go out
Not
and play in the
important.
snow.
Jeez.
I know.
Oh my God.
And then also trying to...
Priorities.
I know. And try
Priorities,
to host
Fraser.
the Weekly Space Hangout. And trying to...
That was my best Morgan. I'm sorry. Sorry, Morgan. Sorry.
You did the
all I
best you
got.
could. Yeah. Hey, everybody. I'm going to say hi to Andy Cowley, Astro B, Ben Kalo, Christian Woodland, Colin Edwards, David Fairweather, Frank Tippin, Ian Farquharon, Gene Charlier, Johnny J, Larry Beckham, Nancy Graziano, Neil Yu, Paranor, Arjone, Roger Haskins, Susan Murph, Therion, and Zapfan. Hey, everybody. Welcome. And other people who haven't said hello yet, or maybe they said hello too early. Anyway.
Keep saying hi.
Yeah, just nonstop. French onion soup takes a while, unless you do it in the Instant Pot.
It does.
That's the key, is you make all the onions.
Why is everybody I know getting an Instant Pot?
Because it's the greatest invention since the beginning of time.
BuzzFeed has been pushing it really hard too on their like shopping lists.
Yeah.
Oh, maybe that's why.
I want the R2-D2 one for my kitchen.
That's a thing?
Yeah,
might be
William
the way
Sonoma
I'll
had
go.
some Star Wars ones.
Yeah.
Of
My
course
entire
they
kitchen is done in R2-D2, so I want one of those.
My Instant Pot
That's nice.
runs almost continuously. Like I have worn one down, and my wife got me another one for Christmas this year because I just nonstop used it.
Okay.
Yeah.
Okay.
Yeah. All like the like the liner, I don't know, there's like a liner on the inside of the lid that was starting to fall apart, and the bearings on it when you put the lid on and turn it, and the buttons have been pressed too much and you can't really tell what does what anymore. So no, it was it was time to move to the new hotness. This one does the sous vide as well.
The new hotness?
Yeah. And in fact, my
Okay.
son is, well, that's the joke, I guess, right? Instant Pot.
I don't know.
Yeah.
I respect the fact that it's letting lots of people who wouldn't otherwise get in the kitchen and cook all this cool, out of this world stuff, like
Yeah.
letting them do that on their own time. I respect that. I like learning it in the traditional way first before I learn other ways. Like I refuse to get a bread maker until I learn how to make bread from scratch by hand.
Sure.
And once I do that, I'm okay with
Yeah.
using a bread maker.
Yeah, no. I
Type
mean,
of
making
thing.
bread by hand is awful. So definitely get a bread maker.
Kinda.
They're the best.
I mean, it's a good arm workout,
Yeah.
but that's about it.
I really like the Zoji Rushi. We have the Zoji Rushi one, which like sings a little song whenever it finishes making bread. Also sings a little song whenever it finishes. We have the Zoji Rushi. We have the water boiler for Carla's tea, and then we have the rice maker, and so it just sings a little song whenever it's finished, and it's just like it's
That's
adorable.
pleasant.
Yeah. It's absolutely catchy.
Wish my microwave would do that.
I don't know if Zoji Rushi
kinda-
makes a microwave. If they did, I'm sure it would sing a little song.
That's an open opportunity for any programmers out there
Yeah.
who wanna help out.
All right. I think we've killed enough time, and now it's time to actually begin the show. So let me put everybody back into the speaker view. There's me. Let's make sure this is going to work. Okay. Here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, January 15th, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about a planet that orbits two stars, the oldest piece of the universe that's ever been seen here on Earth. And Jupiter might have caused our solar system's great divide. Joining me this week on my screen right now is Dr. Kimberly Cartier. Kimberly.
Hello, Fraser. Happy podcast day. Haven't gotten to say that this year yet.
Happy podcast day to you too. And you haven't. Nobody said it in 2020. I'm sure somebody said it last week. I didn't hear the intro last week, so I don't know whether it got said. It
I
should
hope
have.
it did.
Yeah, I think we
Every year needs a
quality
happy podcast
assurance.
day.
I hope was able to make sure that it happened. Let's see. We've also got Moya Mcteer. Moya,
Hello. How's it going?
good. How was your return from Hawaii?
It was
Are you
actually
still
pretty
there?
seamless. No, I'm in New York now. I'm home. But I had a red eye flight and got home, took a 2 hour nap, and then went to work. It was really seamless.
Yeah, not my experience. No, it took us easily 20, no, about 30 hours to get away from Hawaii. Yeah, our plane, as I described, our plane noped twice on the runway.
Oh no.
So, yeah, tried to take off, decided it didn't want to take off, returned to the back to the airport, tried again. No, everyone was deplaned,
Oh,
put in a hotel while we were all, wrecked, and then we tried again the next night. So, but it did work out that time.
it's brutal.
Yeah, but it was great to
I'm
hang
glad
out
you're
with you
back.
in person. Yeah, at the
Yeah, it
at the
was nice.
convention. All right, and we've got Beth Johnson. Beth,
Hello, Fraser.
how's it going?
Pretty good.
All right. Now, before we get into our special guest this week, I just need to say a big shout out and a thank you, of course, to our good friends at the Weekly Space Hangout crew. They are the producers, really the coordinators, really just behind the scenes, getting everything done. And they were especially critical last week when Morgan took over and handled all of the hosting, all of the directing, and I got to jump in, I guess. I have no idea whether that worked out very well on the scene to talk about Starlink, but it was great to be able to have all of their help. So if you want to be a part of this amazing community, if you want to be one of the executive producers of the Weekly Space Hangout, go to wshcrew.space and they will give you all the information you need to be able to join this incredible community. So wshcrew.space. All right, joining us this week, our special guest is Dr. Erin Macdonald. Erin, welcome to the Weekly Space Hangout.
Hi, I'm really happy to be here. Thanks for having me.
Now, you were mentioning the last time we actually hung out was like 8 years ago at DragonCon. We were on a panel. What was the panel?
I think the panel was on, it was a late night panel. I think it was one of those random ones that you find yourself in at 10 o'clock at night.
Right, when someone just grabs you and says, hey, do you want to be on a panel to talk about, and then you're like, sure, whatever, will there be
I think
scotch?
I was still in grad school at the time, and a lot has changed since then. So it's good to see you again, though.
So who are you and what do you do?
So I'm an astrophysicist. I did my doctorate with the LIGO Collaboration studying gravitational waves. Since then, I've got into science communication, and I do science consulting for the aerospace industry as well as the entertainment industry. And most recently, I was announced as the science consultant for the Star Trek franchise. So pretty exciting.
That is incredible. Now, those of us who know are aware of many Star Trek-y things in the Star Trek franchise. There's the new movies, there's the TV shows, there's the Picard show, which I think starts like next week.
Yep.
There's the Lower Decks, is that right?
Yep.
Okay. There's Discovery. So which of these are you involved in?
So basically the way it works is that I've been brought on to be available to the franchise. So, they have their executive studio that kind of operates all of those shows, that runs them. And that's kind of where I work out of, where they will reach out to me. Shows know that they can reach out to me if they want me to review their scripts, if they want me to be involved in their writers' rooms, anything like that. So I'm just available across the franchise. And then I'm also continuing to produce fan content. So I actually got my start doing science consulting by giving talks at things like DragonCon, talking about the science behind science fiction, and been doing that for 8, 9, almost 10 years now. And, it just kind of took off. I started speaking at the official Star Trek conventions, and I've been making videos for StarTrek.com. We posted a How Does Warp Drive Work most recently, so people can check that out. So it's a combination of behind the scenes and then fan facing. It's a dream job.
So I guess if people want to follow in your footsteps, all they have to do is get a PhD in astrophysics, and then also simultaneously just really work on this universe and really try to figure everything out about it, and eventually someone will take notice.
Eventually, yeah. No,
Right.
it's been a long, it's been a long journey. I think a lot of it has to do with the fact that I was very lucky, first of all, that I just happened to do my PhD in theoretical astrophysics, which I didn't think would ever really apply outside of academia. And so when I wanted to leave academia, it was a little bit terrifying. And then, transitioning from that, going into teaching and going into science communication and teaching science through science fiction, being able to blend my love for science and science fiction, that's really kind of where this all came together. And, it works out great. I think a lot of people, especially writers who don't have a science background, who want to tell science fiction stories, if they reach out to scientists, sometimes they have mixed experiences, because sometimes scientists will say, science says no.
Yeah.
Leave it at that. Whereas I'm like, all right, let's do this. Let's yes and this.
Yes,
We're
yes
gonna make
and.
this work.
You want artificial gravity? Yes and. You want warp drives?
Right.
Yes and. Fine. All right. Then have any of the science that you have consulted on, has that actually been broadcast yet, or is this still around the corner?
No. So
Okay.
this is kind of all stuff that's come up. This is kind of a more recent formal job. I've been on the periphery of working alongside Star Trek for a
Right.
long time.
An
But now this is-
enthusiastic volunteer.
Exactly.
Right.
I mean, you're not wrong.
Yeah. I know the
And,
feeling, yeah.
Yeah. But yeah, no, I'm excited to be able to share this stuff and be able to share some of the science that we've put into things. And, sometimes it really is just as much as saying, rephrase that, or let's take that sentence out. Let's, sometimes saying nothing is better than trying to explain it. And so trying to find that delicate balance is not an easy one sometimes.
How knowledgeable are the screenwriters that you're working with about the actual underlying science? Is their knowledge of what's possible and sort of the current thinking in science actually fairly sophisticated already?
Yeah, I've always been really impressed with the writers I work with. And, a lot of writers' rooms, not just Star Trek, when they reach out to a science consultant, a lot of times it's not because they don't know any of the science. It's because it's like they know just enough to be dangerous and they just want a spot check on it. So they say, okay, this is how we understand how space-time or gravity or centrifugal force or anything like that. That's how we think it works. Did we get that right? Like, does that make you throw up in your mouth? And they have incredibly smart people behind the scenes. And a lot of what I do is just trying to, help save them time, take a little bit of stress off of, their pressure. I think we know, especially these days, there's so much content out there,
Yeah.
and the internet is a beautiful but sometimes brutal and terrible place for fans who are particularly eagle-eyed. And so a lot of it is just making sure that it just passes a mustard test. That's pretty much it.
Have you had a chance to work things through the other way, though? Like, I was mentioning last season of this show, we were watching The Expanse, and there's a scene in The Expanse where they're in various forms of zero gravity, and they're having to accelerate in different directions, and it's causing a toolbox to become just this lethal weapon inside the cabin of the spacecraft. And it's a situation that I don't think anyone really thought through, but because they understood just how the actual physics works, it created a scenario, thanks to the science, that was really dangerous. Have you had a chance to go, here's something really cool that we've just discovered, and maybe it has some implications that could work out in a story?
That's That's a really good question. I really like that example you give. I'm catching up on The Expanse right now, and so I'm always like pausing it to scroll down notes because of things like that. Like, you never thought there would be so much tension around a toolbox suddenly being in zero G, and you're just like, oh no.
Yeah, exactly. Yeah.
But yeah, I think one thing that I've really enjoyed bringing to a lot of rooms here and talking to writers about is gravitational waves. I think people are excited about this. It's opened up a new world for astronomers, but as well as for writers. So I think I didn't consult on this show, but even the recent Voltron Netflix series, they said like the gravitational waves from the nearby neutron star are disrupting our sensors. And I was like, you just used 80% of my thesis title. And so
you just didn't include Voltron.
Yeah, exactly.
Yeah.
So, I think that with all of the cool things that we are discovering and continue to discover in space, science fiction writers always have an ear to that. And they're just, kind of like, oh, what's the thing that I can use? But, a lot of when I'm asked, what's the thing you're most like working on? A lot of times it has to do with the cosmological address, which science fiction screws up all the time. So conflating star systems versus galaxies versus the whole universe. They'll say, oh, these aliens came from a nearby galaxy. Probably meant star system.
Yeah.
And then actually the poster right behind you about gravity wells sucking. That's another thing. Gravity wells, things fall into gravity wells. And but these stuff are just so commonplace around us that those are, little tweaks that we need to make sometimes.
Yeah. I mean, it's actually kind of surprising even when you go back and look at the original Star Trek episodes, how well they do hew to a lot of the modern science that was getting figured out at the time. Antimatter, even teleportation, a lot of these ideas that we take as just these mainstays in science fiction were really cutting edge science, that cutting edge physics at the time that they were then applying to the shows. And now, I mean, there's all this new stuff, as you said, right? There's gravitational waves, and there's neutron stars and colliding neutron stars and black holes and all this kind of stuff. And it's dark matter, probably dark energy.
Yeah. Well, I love the sort of probably, apocryphal story that the term black holes was first coined, I think, in a paper in 1967, around the same time that the original series used the term there's a hole that's black in space, and so things were skirting around that, but the actual phrasing, I love that tie-in. And you're right. I think, Star Trek has always had an ear to modern science, and I think has also, inspired so many people like myself and probably a lot of us to go into science, to be like, you know what? I want a transporter. Like, how can I make transporters and actually follow down that path, which is just awesome.
Yeah. I mean, I think that some of us either participating in the show or watching the show got excited about space and astronomy because of science fiction. And you want to know more, and then eventually you have to learn sort of the formal version. More turns into school.
Yeah, funny how that happens.
Yeah, I know. And yet it's funny because now I'm seeing less of people being absolutely inspired by, say, like what's happening with science fiction, and more what's like literally happening with reality, thanks to things like SpaceX. So it's kind of amazing how now reality is catching up in ways that science fiction was only dreaming about 20 years ago.
Yeah, and I think a lot of that is just the world's got smaller. I legitimately, I say this all the time, that I really was inspired to become a scientist because of Dana Scully. But I didn't have Twitter. I didn't have the internet. I had reruns on Fox at midnight when I was supposed to be in bed that I would watch Dana Scully fight aliens with science. And so my world was a lot smaller than I think a lot of kids have now. They do have exposure to scientists online, and they have exposure to a lot more cool stuff that's actually going on. Whereas, for someone like me growing up, I just kind of had my nearby neighborhood, and that was it. And that's still, you know, it was good, but that representation is so important, because if I didn't see a redheaded woman as a redheaded girl using science, I wouldn't have necessarily seen myself in that role.
As a science communicator, I can confirm that it is there's, you know, and you're on the internet and people are nitpicking the work that you do. It can be a little demoralizing. So have you gotten any sort of advice from the people out there who have gone before you about like what it's like, you know, Kevin Grazier or Phil Plait? Have they given you some you know, some guidelines to prepare yourself for the kind of storm that you may run across?
Yeah, I know both of them very well. I've been very lucky. Phil and I were both on the Star Trek cruise together last year. So we've had a lot of time to have these conversations. But you know, for me, what's most important is staying positive and remembering why we all love these things in the first place. You know, it's never going to be perfect. And I have to explain to people that sometimes we wear a scientist hat, sometimes we wear a sci-fi fan, and sometimes you have to sacrifice science for story. And that's fine. You know, I remember too talking about The Martian, that, you know, the whole story wouldn't have happened if there hadn't been one glaring scientific error.
Windstorm
Yeah. On Mars. But you need the story, and you know, the writer doesn't want that to be the fault of any of the crew, and so you have to make an environmental disaster, and by doing that you have to break some science. And so just continuing to stay positive, reminding ourselves like why we get excited about it. I think that's, for me, is I'm here to make the stories a little bit more fun, to just enhance them a little bit, but I'm not here to say, yes, this is totally right, or no, this is totally wrong. The writers are the ones who are coming up with these beautiful, amazing stories. I cannot take credit for. All I can do is be a resource to them, help out as much as they can. You know, I submit changes sometimes that just end up, the scenes get totally dropped. That they just go, you know what, we're just not going to worry about it. Thanks.
Like we're not going to worry about the science, or we're just not going to worry about this whole storyline.
We're just going to wipe the storyline, because if we try to fit that science in there, it's just not going to work. It's just not going to work. There's no way we can do that. And so sometimes there's that like little burden, but I just, again, trying to be that yes and positive force to help tell the stories, not to, you know, kill or tell stories myself.
So is there anything in Gravitational Waves that you're working on?
No, other than following it, you know, pretty closely on Twitter and getting occasional messages from my friends who are still in LIGO. My friend, you know, I have a friend, Laura Nuttall, who's a professor now at Portsmouth, and we both did our PhDs together in the UK. And we, you know, I left academia, she stayed in it. So we follow each other's paths. And anytime we feel that tug, we just remind each other why we left or why we stayed. So I do get occasional anecdotes from LIGO, which I appreciate. But it's interesting, you know, just, I mean, we might as well, this is Weekly Space Hangout, but there was a lot of buzz today that there was a gravitational wave alert from the vague region of Betelgeuse. And everyone was like, oh, I mean, it's not, but it's not. But
it's not, yeah.
You know, I'm grabbing my jacket.
Yeah.
Like,
it's still dimming.
Yeah, exactly. But I do want to note, though, I think there was a lot of misconceptions that LIGO is just designed to detect coalescing binaries, that it wouldn't detect a supernova, and that's not correct. Like it was optimized to detect coalescing binaries, but it absolutely could detect a supernova if one happened close enough to us. It would just come up as a different type of signal. It's an unmodeled transient signal is what they talk about, whereas coalescing binaries are modeled. We know what that signal should look like. We don't know what an exploding star would look like, but now we have enough detectors up that if we get them coalescing with a big kaboom, then we can go, oh, that's the same thing. So
I mean, LIGO is just an incredible engineering accomplishment, Nobel Prize winning. People weren't even sure that it was even possible. And then there's advanced LIGO, and now there's LIGO Virgo. The science is continuing apace at this point. What are your sort of fantasy hopes for where the science of gravitational waves goes? What would be that, if 50 years from the future you sends a message back in time,
You're going to love this answer because it's all going to go together.
Yeah.
So, first of all, if anyone came here because of Star Trek and have no idea what we're talking about, LIGO is the collaboration that detects gravitational waves. This is international, 80 plus institutions, over 1,000 people who work on it that have built these detectors to detect gravitational waves, and which are ripples in space-time. I worked in LIGO during the dark ages where it was hanging on by a thread, and I did leave right like a year before they made their Nobel Prize winning detection because there were no jobs because we weren't making any detections. And it was hard to continue justifying the existence of LIGO. I wanted it to continue, but the jobs just weren't there. And I'm immensely proud of everyone there who's stuck with it and has hung in and have made amazing careers of it since then. But the analogy I always give is that all of the astronomy that we've done up until now has been like through our eyes, through different spectrum, but with our eyes, whether it's radio waves, X-rays, visual gamma rays, that's all electromagnetic radiation. Yeah. Gravitational waves are like hearing for the first time. They're not sound. Sound doesn't travel in space, but it's like being able to hear for the first time. And so I can't wait to figure out what we're going to learn. Now, where I really want it to go is, my theory is always like, all right, first you theorize about something, then you detect it, then you indirectly detect it, which we did. We got gravitational lensing. Then you directly detect it, which we just did. Then you learn to play with it. And when you learn to play with space-time, you get warp drive.
Right. Once you manipulate space-time, then you get warp drives. Right.
Exactly. Because warp drive just works on the premise that, nothing on the surface of space-time can't go faster than the speed of light, but nothing says that space-time itself can't go faster than the speed of light. So if you can warp a bubble of space-time around your ship and that pushes faster than the speed of light, okay. Well, I'm like more optimistic about warp drive than I am about landing on Mars.
Really? Clearly.
I'm just excited about it.
I think you find if you studied gravitational waves, this is very difficult.
Yeah, it's true. But all I want to do is join Starfleet. We can't have Starfleet until you get warp
But you
drives.
can join Space Force.
Yeah, that's right. Yep, exactly. That's a thing now.
Yeah, that's a thing. Although, I've been pitching constantly that they should change the name to Starfleet. If they change the name to Starfleet, then maybe they will behave like Starfleet. And then that will just be just a better path for the whole process to go.
I've worked with a lot of Air Force who are now Space Force, people who would be right there with you.
Yeah.
They joined because they wanted to be in Starfleet the same way I became a scientist because I wanted to join Starfleet. So
when can we look forward to the first thing in some form of media that you had a chance to correct the science?
Oh, geez. Stay tuned because I'm not sure exactly when any of this stuff is coming out.
Well, the new season of Discovery starts very soon. Picard, I think, starts in like a week.
Picard starts in a week.
Yeah.
And then the Lower Decks is coming. But you got to remember, Hollywood's a long churn of things. So they've been working on this stuff for a long time. And people are like, it is the 11th hour and 59th minute. And I'm glad we have a science consultant, but do not come near my script.
Right.
So that's fine. I respect that.
So you have no idea.
Season 2.
Yeah. You could watch it and go, hey, I helped with that. Or, oh, no, they completely ignored me again.
Yeah. There's exciting stuff to see. I'm excited for all of the shows that are coming out. I think we are in a new golden age of Star Trek, that there is so much content that's going to, please so many different kinds of viewers. And I hope continue to bring younger viewers, people from different backgrounds into the Star Trek community, because the Star Trek community is one of the most loving, giving, friendly, kindest places I have ever been. It was my introduction to fandom, was like the midnight release of the, Kelvin timeline, like over 10 years ago now, film. And I was like, oh, I get it now. Yeah. Like, I get this is my people. This is where I want to be.
Well, it's nice to balance out the fandom of that other Star fighting show or something,
Which
whatever
I
it's
also
called.
love, but
Yeah.
yes.
Kimberly is the yin to my yang in this field.
Though I will say I have officially started watching Star Trek
Welcome to the
way
club.
way back in like original series. I'm in
Awesome.
season 2. I'm getting through it.
Oh
So-
no!
You know,
Yay, that's
power
rough
I'm
to
though.
working
you.
on it.
Speaking of
I
things
gotta
that
do
don't hold up.
Yeah, that's
Yeah.
that's actually a rough
Chronologically.
start.
That's not
This is
the
true.
easiest.
I
I
decided-
respect you.
It took willpower to stick through it, but I'm in season 2 now. So
I've tried to rewatch some of those, and I definitely have moments of oh, ow.
Yeah.
you sort of have to want to love it a little bit.
My wife is a gigantic fan of the original Star Trek, the old show, but didn't really care for the Next Generation. But she's kind of like toughing her way through it now, and so she's
Ooh.
like actually just like on season 7 right now, and then we're gonna go through all the others, which is sort of a declining path down.
I think Voyager and Deep Space Nine are some of the most accessible to new viewers. They're different styles.
Yeah.
DS9 lends itself very well to streaming because of the way it's story. Like it was hard to keep up week to week. And then Voyager, I have a soft spot, obviously, for Voyager.
Yeah.
So yeah.
So if people want to watch what you're doing, and I'm sure you're going to make some mentions on some kind of social media thing, where can people find out more?
Yeah, so I'm most active on Twitter. It's at Dr. Erin Mac, Dr. Erin Mac, ERIN MAC. And that's kind of where I am the most. I also have a YouTube series called Dr. Erin Explains the Universe, which hasn't been updated in a while because I've been busy doing other things, but you can watch my old videos on there. And then my website is currently being updated. I haven't made any announcements for 2020 yet, except for the Star Trek cruise, which is going to be happening in March and is already sold out. So I'm
Fantastic.
Yes, it's going to be fun though. Stay tuned. We got a lot of fun. 2020 is going to be a blast. And look out for my videos on StarTrek.com as well.
That sounds great. All right. Well, Dr. Macdonald, thank you for joining us here on the Weekly Space Hangout. Congratulations on this epic gig, and keep us posted on everything you're doing.
Thank you very much. Live
All
long
right.
and prosper.
Oh, nicely
Bye.
done. All right. Take care. All right. Beth, you're on my screen.
Okay.
What do you got?
So, big story last week out of AAS was that a high school intern discovered a circumbinary planet using test data. And I've seen it everywhere, and everybody's hyping up the fact that it is a high school intern, and I just think that's amazing. I just keep saying that astronomy is one of those things where you can do all of the research for all of the years, and someone punk is going to come along and have a lucky break in 3 days. And that happened to me in my undergrad, so I just find it hilarious that it continues to happen to other people. So,
But isn't it partly now there's like so much data that if you're like a real go-getter, you could just dig through that data and find a planet? I mean, there's like
absolutely,
4,000 of them, right?
He was literally on the job for 3 days looking through the data. So, I mean, that's just, hey, this thing looks like it might not be an eclipsed in binary. It might be a planet. And everybody goes, oh, well, let's check it out. And then, they went through the radial data, the radial velocity surveys, and they figured out, yeah, no, there's a planet there. And so now this high school kid's living on
Yeah.
high on the hog right
Yeah,
now.
all those exoplanet riches.
Yeah.
Kimberly, I believe, can speak to that. So tell us about the planet.
So the system is TOI 1338, and TOI stands for Test Object of Interest. So as always, naming things in the most interesting of ways. It's in a system that's about 1,300 light years away. The constellation is Pictor for those who care for staring at a star they can't see. The binary stars go around each other every 15 days. And then the planet has an irregular orbit. So it goes 93 and 95 days, depending on where it's in its orbit. We only see it crossing the larger of the two stars. The other one, it's too faint to see the changes in the light. It's about 6.9 times larger than Earth. So we're talking about Neptune-ish sized. And so we get lots of nice little stellar eclipses that we can see, but eventually they're going to go away for a little while and then they'll come back. So it's just slightly off angle. So we're kind of lucky that we're getting that view right now.
And so, I mean, the planet is going around two stars.
Yes.
So what's the geometry going on here?
So you have two stars,
Okay.
and they're going around each other like this.
Yeah.
And then you have one planet that's going around both of them. So
Right.
and one star is bigger than the other, so that's what kind of swings the orbit out a little bit more on either side. So you have a lot of very interesting gravity interactions that change the orbit of the planet.
And I know that there are a couple of situations where you can have, this Tatooine, speaking of star fight movies, there's this idea of like Tatooine, right, where you can have multiple suns. And so I'm sort of kind of imagining the geometry here where you're going around these two stars. And so sometimes both stars will be in the sky, and then sometimes both of them will be, and they will rise and set. It'll be they'll be kind of roughly close to each other. So that's probably like a better example of Tatooine than maybe the other stable scenario where the stars are super far apart and your planet is just orbiting around this one star, and then the other star is, 500 astronomical units away and has its own planetary system.
Yeah. I think everybody's kind of, between the high school student and the Tatooine aspect, the story has sort of gone a little crazy.
Yeah. Well, it's possible we covered it. So, but is it actually an eclipsing binary system? I mean, it's both, right? It's both.
Yes, it is both. It's just that then I guess the thing is that the timing of the eclipsing was not working out mathematically to just be an eclipsing binary. So one of the things that I think is really cool is the software package that they use to analyze this is called Eleanor, and they named it after Ellie Arroway in Contact, which I
cool.
just, as a SETI person, I think is absolutely hilarious and wonderful at the same time.
I wonder if this is a newer methodology because, like eclipsing binaries are fairly well known. But to actually take another look at these eclipsing binaries to see if there's also a planet as part of the package, I wonder if that's more of a newer idea.
Well, they're expecting TESS to find thousands of eclipsing binaries now that it's up and running and looking at the sky, and they figure there's probably a lot more circumbinary planets out there to be found in the data.
Yeah, that's super cool.
So one of the things that I found really cool about this one is, like you said, Beth, we were really lucky that TESS caught it when it did, because the transits are going to go away soon. I think something like 3 years from now, we're not going to see transits for a while.
Oh.
And so like you said, we're really lucky that we caught it right now, which puts me in mind of Chaos, which is a follow-up mission going back to a lot of systems that we already know are there. And I'm wondering if maybe we'll catch a couple other really lucky ones that we weren't able to see with Kepler or K2.
Well, I think a lot of astrophysics is luck. I mean, especially with exoplanets, when you're using the transiting method, you have to have that perfect line almost. And, you tilt just a little bit and you've lost it. You can't see anything. So yeah, there's a lot of luck involved. There's so many levels of luck in this discovery that it's kind of what makes it amazing.
Moya, weren't some of your the students and people that you worked with giving some presentations at that TESS press conference?
Yeah, I think there was a student who was an undergraduate at Columbia, Gabby Suisa, I think is her name. She was on a team that found a planet in an Earth-sized planet in an habitable zone with escape.
That's right. Yeah, it was like the TRAPPIST system, except less planets. But there was a habitable world. It was the first habitable zone planet that TESS has found so far.
Yeah, I think it's the third planet from the sun. So that's fun.
And speaking of
sun in a different solar system.
And speaking of planets, have you guys heard the rumor that there's another planet potentially orbiting Proxima Centauri? They've found a super Earth.
You mean Proxima C?
Proxima Centauri C. Yeah. I guess you have.
I wrote about that like in August.
Oh, I thought
So it's
They've
been
been
a while.
talking about this for like a year, trying to verify it and get more data.
Oh, really?
This,
I
this
thought it was
particular
new.
team.
Okay.
Well, it's probably newly confirmed, or they maybe not confirmed, but more evidence pointing in that direction. Because they've been talking about it for a year or so.
Okay.
And some of the results were preliminary, some of them were suggestive, some of the error bars were just a little bit too big to be believable. And then they got a little bit more data and it was more convincing. That's when I heard about it. And they probably have even more data now to try and tighten things up. So
Yeah, I think it came out in the journal Science this week, and that's why it triggered another round of
popped up again.
Yeah. No, I hadn't known that it had been announced several months, but clearly that's.
I mean, I'm really glad that they've been getting more data that seems to be consistent with the hypothesis. I mean, it's super exciting, just to like hone in on this particular result.
Although weirdly, you would think that it would be easier to find planets going around the Alpha Centauri's A and B, but I guess not, because Proxima is
It
dimmer,
depends on,
right?
it depends on your alignment and depends on what telescope you're using, and yeah.
Although, it's our closest stellar neighbor, and yet it's still so ridiculously far away.
It's a mystery.
Yeah, exactly. Kimberly, you're on my screen. What do you got?
Sure. So, imagine, if you will, 7 billion years ago, the sun isn't here. We're definitely not here, but there's a burst of star formation going on in the Milky Way. And some of these stars die and then fling all of their material outwards into the galaxy. And not too far away, a couple billion years later, there's a tiny little yellow star forming and then forming some planets. And some of that faraway material gets incorporated into this newly forming solar system, if you call it that, And then a couple billion years later, a tiny rock falls to this tiny blue and green planet in the middle of Australia, let's call it, in a place called Victoria. And then someone finds it, puts it in a museum, chops it up into bits and puts it in a research laboratory and doesn't touch it for like 51 years. And then someone decides to grind it up into pieces, dissolve some of it in acid, and detect all sorts of material that they find comes from this burst of star formation 7 billion years ago. That's what happened. And that's exactly what happened and what we learned about earlier this week. And what's really a couple of really interesting points that I sort of glossed over. 7 billion years obviously predates the sun. And not only that, but it makes these tiny little specks of stardust, actual stardust, the oldest solid bits of material on Earth, which in and of itself is like super cool.
Well, Carl
Right?
Sagan always said that we're made of stardust.
We are made of stardust, and so are our meteorites, and some of them, about 5% of them, come to Earth with these bits of stardust in them.
So what is stardust made of?
I mean, it's made of, the same stuff that we're made of, carbon and silicon and iron and things like that. But the way that we tell that it predates the solar system is not so much the composition, but the amount of exposure that these grains have had to cosmic rays. So the longer that a bit of dust is exposed to cosmic rays, the more those cosmic rays will interact with the surface of these grains and alter some of the molecules. And these are sort of molecules that only come from the interactions with high energy cosmic rays that are found outside of a solar system in the galaxy. And by measuring the amount of exposure or weathering these grains have had to cosmic rays, you can get an idea of how long these grains have been exposed to those cosmic rays. So that's sort of how we get the 7 billion years. But another really interesting part of this story is sort of what I started with, that there was a burst of star formation nearby in the galaxy. Because one of the things we're still trying to figure out for the Milky Way is how frequently stars form. And do they form all the time at a steady rate? Or are there sort of bursts of star formation in localized areas, sort of sitting on top of a slightly lower star formation average, sort of to get the number of stars that we see? So this is a little bit of evidence that there was at least a very small localized burst of star formation sort of near where the sun is now. It's kind of cool, I think.
Yeah, I mean, I know that one of the really fascinating discoveries that astronomers made as they started to date meteorites is that they're all the same age. They're all 4.6 billion years old, no matter where the meteorites are. And then that tells us that all of the objects in the solar system all formed around the same time. But then they find a tiny bit of stardust grain.
Yeah. And about 5%, we've detected some of these pre-solar grains, they're called, and about 5% of the meteorites that have fallen to Earth. So it's not a new concept,
right, that
stardust from before the solar system can embed themselves inside meteorites and make their way to Earth. We've sort of known that for a while, but these are some of the oldest grains. And this particular meteorite called the Murchison Meteorite, it's a pretty well-known one, if you're into meteorites and stuff like that, which I sort of am.
Who isn't?
There were quite a number of these pre-solar grains all in this one. It was a tiny section of the meteorite that was squirreled away for scientific research. And that's where they get the idea, because so many of the grains are approximately the same age, still older than the solar system, that they all come from a burst of star formation about at that time.
I wonder if they can resist just grinding up the whole meteorite. I mean, it's a very famous meteorite. It's very important and valuable.
Meteorite. There are sections of it in a bunch of museums around the world. There are thin sections of it floating around in different petrology labs in classrooms. I think I studied it once upon a time in undergrad. We were very lucky to get our hands on a thin section of that one. So likely no, unless we never want to study it again.
Right, but I mean, if you find one that's 7 billion years old, maybe you're going to find one that's 8 billion years, maybe one that's 9 billion years. If you just keep grinding up this poor meteorite, you might just keep beating the record, and eventually, there'll be no meteorite left. It would be super cool.
And I mean, we've talked about with the interstellar asteroids and comets, Borisov and Oumuamua, that they are pieces of other solar systems that maybe one day we'll be lucky enough to study if we can ever get a sample of it. These are samples from other stars, like actual physical samples from other stars that we do have our hands on now. They're just really tiny.
Yeah. And so, I mean, you think about the sample that's coming back from OSIRIS-REx. Can you imagine some future mission bringing back a sample that's bigger or whatever, and then maybe them grinding it up in space and performing this kind of experiment so that it can't be contaminated by Earth? Like you can imagine this sort of going at an industrial scale, and they may get to a point where they can really, it's almost like archaeology, right? That you can start to understand when these different supernova explosions happen. It's like archaeology of the galaxy. Yeah.
It's archaeology of the galaxy, getting little bits and pieces of information from a time before we were around, and building up this history of our galaxy piece by piece, until maybe we'll be fortunate enough, if we ever get warp drive, to actually go and explore it.
Yeah.
And get a Rosetta Stone type of thing.
Yeah. But I do love that idea of starting to map out the history of the local environment. Because I mean, I know that people have estimated that in fact there was a neutron star collision that probably happened in our local environment X 100 million years ago, or billion years before the solar system formed, to help seed some of the heavier elements. And you can kind of imagine, if they could do it carefully enough and figure out the different ages, you could actually know that this kind of supernova went off and then this one did, and sort of build up the history of the pre-solar system to know just really what came together to make us. So Carl Sagan was really right. Really, really right. Moya, what do you got?
All right. I'll try and be fast. I'm going to talk about Jupiter.
No problem.
Okay. So scientists who study the formation of the solar system tend to separate it broadly speaking, into two locations or to two regions. There's the terrestrial zone, so the inner solar system with Mercury, Venus, Earth, Mars, and like the asteroid belt. And then there are the Jovian planets, that's Jupiter and everything outside, further out in the solar system. And the demarcation line between these two zones is sometimes called the Great Divide. And it's been hypothesized for a really long time that Jupiter, because it's so massive and has such a strong gravitational field, is responsible for this Great Divide. There are a lot of differences between the terrestrial and Jovian planets, like the size and their composition, but people tend to really hone in on the difference in like how much organic matter there is in these two zones. And it turns out that there's a lot more organic matter, a lot more organic compounds in the outer solar system than there is here in the inner solar system. So we thought that Jupiter was responsible for it for a long time, but a paper came out in Nature Astronomy on Monday where these two collaborators, one in Tokyo and one in Boulder, Colorado, they'd done some simulations on the formation of the solar system and found that Jupiter actually didn't get massive enough, fast enough to be responsible for the Great Divide. So they kind of shot that hypothesis out of the water, and their new explanation, their proposed explanation for the Great Divide, comes from ALMA data. So ALMA, the Atacama Large Millimeter/Submillimeter Array, is a really powerful interferometer in Chile. So it's in the southern hemisphere, observing in the radio, and it's taken these really beautiful images of forming, like actively forming planetary systems. If you haven't seen the pictures,
I'm gonna pull it up on the screen so people can see this. Yeah.
Great. Yeah. I remember when these images came out, I was like, my mind was blown. They're so beautiful. But you can see these dark rings in these images, and those rings are places where planetesimals, or baby planets, have kind of swept out all of the dust and matter as they're colliding with each other and growing into full-blown planets. And when the planetesimals sweep out this area and form this empty space, they are actually also creating pressure differentials throughout the disk. And so the empty spaces are areas where there's really high pressure, a pressure maximum, and material has a hard time getting over this pressure gap. And so these two people who wrote this paper think that either one very large gap or a series of gaps over time made it so that organic compounds from the outer solar system couldn't really get into the inner solar system. So it's not Jupiter's fault that we don't have more organic matter. It's just a high pressure system from around the part of the solar system where Jupiter happened to form.
I mean, so far, actual Jupiter mass exoplanets haven't been found very often, right? Like, and nothing sort of really like a duplicate of Jupiter. But you're seeing these with ALMA. You're actually able to see all of these these newly forming planets clearing out the dust in their disk in a way that you can't see with any of the methods of the transit method or the radial velocity method. It is just this whole different way of scoping out the planets that are out there.
Yeah, because it's before the planets form.
Yeah. And so do you think that we will see, we will get this sense on just how planetary systems tend to form, and we'll see these natural divides in the way that we have in the solar system? Is that starting to happen?
I don't think that there's I don't think the relationship between like the size of the gap and the characteristics of the planet are that like one-to-one. I don't think it matches quite that easily. But I think that we definitely can learn a lot from getting more examples of these planet-forming disks and seeing things like how the overall size of the disk relates to the size of the star, the mass of the star. Even that is like an unanswered question in astronomy that I would love to see an answer to.
I was gonna say it almost feels more useful to us than finding individual planets with the transit method or the radial velocity, because you just get, some hot Jupiter that's swirling around its star. But with this, you just see the whole planetary system like a record, and you can just map out exactly its structure or what it's going to turn into in the future, you hope.
Yeah, almost like a fingerprint. Like if you could see someone's fingerprint and then work out to figuring out what that person looks like, that's kind of that's what we can do with ALMA.
Yeah, incredible. It's one of my favorite. I know exactly what you mean. I give a presentation about sort of the future of telescopes and some of the cool things that are happening right now, and I lead with that picture as just some of the greatest photographs that I think have ever been taken in the field of astronomy, because you are literally looking at a newly forming planetary system. And in some of the pictures from the Very Large Telescope, you can actually see the planets themselves, thanks to the sphere instrument that can detect the polarization of the light coming off of these planets. So it's kind of mind-bending what's possible today.
It is, yeah. And I wish that people knew how important these moments were to astronomers, because we, as astronomers, we like send out images of space or like artists' impressions of space all the time. And I think that a lot of people who aren't astronomers, they get maybe desensitized, like they don't know what's a real image and what's an artist's imagination. But when you get to see something like HL Tau and realize that it is an actual image that a telescope took, like that's a really powerful moment for an astronomer.
And I
wish more people knew that.
And it's going to just get better. Moya, you were on my screen. Tell us what you're working on and where people can follow more.
You can find me. I'm mostly on Twitter. My handle is GoAstroMo. And right now I'm working on a sci-fi story that I'm developing for my show at Caveat. So I have a story about a space anthropologist who travels to different planets to meet the locals and learn about their culture. And along the way, she gets wrapped up in a mystery with her missing mom. And so I'm really excited developing that. And that'll be out, come out in installments over the next year.
What form is that going to take? Like, is it like written podcast? What's your plan?
They're going to be short little animated videos.
Oh, wow. Okay.
And each video will be shown in my live show at Caveat, following a discussion about the life and culture on the alien planet featured, but I'll also put the videos online.
Okay, so people can follow your YouTube channel. Where can people, if they want to be able to see this stuff, or follow you on Twitter?
I haven't figured that out yet. So yeah, follow me on Twitter, and then you will know what's going to happen as soon as I know what happens.
Yeah. All right. GoAstroMo on Twitter.
Yeah.
All right, Beth.
I can be found on all the things as Planetary Pan. And right now I'm working on a lit review on atmospheric composition of exoplanets in order to help Pamela do some art.
Excellent. Kimberly?
Oh, let's see. Right now, I'm actually working on a story about this meteorite with the Stardust, and also a story about how tardigrades may fare under climate change.
I saw that. Yeah.
Yeah.
Poor.
Maybe not so well.
Is this their kryptonite?
Kryptonite, Achilles heel, whatever analogy.
Yeah,
you
I thought the tardigrades would bury us, but apparently
no. My editor and
is...
I are pretty sure that they're going to adapt, and so then when we're all gone, the tardigrades will rule the sea, and the cockroaches will rule the land.
Right.
And then no one else will survive.
So we should.
This is what we're pretty sure is going to happen.
Right. So we shouldn't pity them necessarily. We should fear them.
They're still hardy little sea bears. It's okay.
Yeah. All right.
And you can read all about that on eos.org and follow me on Twitter at AstroKimCartier.
Fantastic. We've got a video this week on my main channel, an interview with me and Dr. David Kipping about whether or not the aliens are watching us, and really it's about the ways that we will look for technosignatures just by the kinds of things that we do here on the planet. But he actually took it one step further and has actually figured out ways to try and cloak our existence so that the aliens won't spot us. So if you want to see that conversation, that's on my YouTube channel. And in 2 days, I've got an episode on Starlink. So, of course, I was at the American Astronomical Society meeting, got to see SpaceX talk about Starlink, got to see the astronomers talk about Starlink, and now I'm ready to give an update on Starlink. Spoiler alert, it's bad. So, that'll be coming on Friday. All right, I'll put everybody on my screen. There's all of us. Fantastic. Well, thank you, everybody, for watching us today. Thanks to all my co-hosts for joining me. Thanks for a special guest. Thanks to all of the moderators and the team at the Weekly Space Hangout crew, especially Nancy Graziano for, I'm sure she did a million things this week, and we couldn't do this without you, Nancy. So, as always, thank you. Thanks to the cat. Finally, we gotta have a cat in every episode.
That's number 2.
That was number 2, yeah.
Right. All right. And we will see all of you next week. Thanks, everybody.
Bye.
Bye.
I lost my end button. There's the cat again. All right. Now I'm going to press the end button.
There would have been